Hello, my name is Hideo Nagahashi, and today I want to talk about the exponential model. So that's the model using exponential functions. So let me start. So let's look at the concrete situation here. Okay, so suppose in the year 2000, the population of an island is say 6,000. Okay? Then 3 years later, population is so suppose population just increased to 10,368. Now, of course, only these two data. You might want to know the more data, but suppose you only know these two. Okay? So again, you can just predict the future by using couple models. But now I want to use exponential model. Okay? So the task is use exponential model to predict the population in say 2010. Okay? So here, what I mean by exponential model is to analyze this. So we use exponential function, which we have studied earlier. So remember, the exponential function looks like p is equal to a times the b raised to t. Okay? So based on this, the formula. So now I predict the future. So the first thing we have to do is to determine these two parameters here. So t is input, p is output. So here, so we plug in the value later on, but so we have to know what's the a and b. Okay? Then to do this, since the year is 2000 and 2003 is very huge, so I can use this one, but to make things simpler. So let's say this corresponds to initial. Initial means, so let's say the 2000 corresponds to t is equal to 0. Okay? So that's the initial value of this exponential function. Okay? So then now you can just make things simpler, because if 2000 is t equals 0, so now the 2003 corresponds to t is equal to 3, okay? 3 years later. So instead of this huge number, so let's use t equals to 0 and 3, okay, to find the formula. So what you have to do is the t equals to 0. So that corresponds to p is equal to the initial population is the 6,000. So you simply plug in these two values to this formula. So it's 6,000 is equal to a times b raised to 0. And then remember, the b raised to 0 is 1. So that's why this just simply said that a is equal to 6,000. So, well, remember if you already know that, no? So this a is actually the initial value. So that's why this part, you can just do the shortcut. So you can immediately see that, 6,000 is the initial population. You plug in. Okay? So 6,000 for the a. So anyway, so this is the detailed explanation. Okay? So why this is initial. So now, a is determined. So now, how about b? So to determine b, so you need another information, so which is here. Okay? So t equals to 3. Then we know the population is 10,368. So again, you plug this in. Okay? So the p is the value, then, well, A raised to, but we already know A, so let's use this one, okay, already. So A is 6,000 times B raised to, now the year, T is 3, okay? So now you have the equation of B, okay? So what you have to do is to use algebra to solve this for B, okay? Then to do this, so let me just switch this one first. So 6,000 B cubed is equal to 10,368. Then, so first you want to solve this for B cubed. So you divide both by 6,000. Okay. So just using calculator, so you can easily get the value for this quotient. So B cubed is equal to 1.728. Okay. Then now to solve for the B, so you have to take cubic root or equivalently. Probably your calculator probably can do this, or this is equivalent to raised to the 1,000 power. Okay? So then, so they're just equivalent. Okay? So you can just compute either of them using calculator. Okay? So using calculator, let me go here. We have B is equal to 1.2. Okay? So this is your base, and also this is called growth factor, okay, in this context. Because now you plug AB back into the original model, you have P is equal to 6,000 times 1.2 raised to T here. So this means every year, so population just increase. So you multiply 1.2, okay, to the previous year to get the population in the next year. So 1.2, so this is called growth factor. And then recall that if you subtract 1 from this, so you get 0.2 or 20%. So usually people call this the population just increases 20% every year. So then when you see that in the newspaper, things like this, so that's this called growth rate. Mathematically, the growth factor is more direct, simple, because it's just directly corresponding to the base here. But in the daily life, people prefer growth rate here. Okay? Okay, so finally, we can predict the population in 2010. Remember, the 2010 corresponds to, now T is equal to 10. So what you have to do is, so you finally plug in 10 to the formula. Okay? So 6,000 times 1.2 raised to 10. So again, you can use calculator to do that. So we get we roughly get okay, the 37,150. Okay, thank you.